performance. Start now.
Okay, this talk is a summary of a paper in review by Ed Liu and Maureen Phelan from the Botanic Gardens in Sydney and me. So why did we do this work? Well, that's a question that we were certainly asking ourselves after doing the work, because it ended up being a gargantuan project. But it really started off from funding that we got from Saving Our Species program in New South Wales, which required us to prepare a hygiene guidelines for our field staff. And we thought, well, that's going to be easy because there's so much information on hygiene and how to do hygiene on the web, and we can just steal somebody else's methods. But when we looked a bit more closely, we found that there wasn't really anything that told us whether those best practice hygiene methods worked or not. So we decided to find out for ourselves. So we decided to set up experiments to test whether 3 commonly used pieces of equipment for cleaning boots worked under 4 different soil and moisture types: dry sand, wet sand, dry loam, and wet loam. So the first piece of equipment was a portable hygiene kit containing a brush and a spray bottle with either equipment 1A 70% metho or equipment 1B 2% phytoclean. So the boots were removed prior to cleaning, and I'll explain why that happened a bit later on. And each component of the equipment was tested separately and together. So the second piece of equipment was a deconstructed device with a fixed brush and a 10% phytoclean foot bath. In the field, these devices have a spring-loaded pressure plate covering the bath of phytoclean. Each boot was placed in the foot bath for 20 seconds, and each component of the equipment was tested separately and together. The third piece of equipment was a device with a fixed brush and a pump-activated 10% phytoclean spray, and we were able to borrow one of these because it was being replaced after the bushfires. Components of this device weren't tested separately. Okay, the reason for cleaning the boots was explained to our volunteers, and that was that Phytophthora can be spread in soil on boots, and it causes lots of environmental harm, and so removing soil from boots is really important. And the volunteers were supplied with signage, which is typically seen on walking tracks and relevant to each piece of equipment. There were 20 replicates for each treatment. So the controls with no treatment involved volunteers walking in infested soil for 30 seconds. And the amount of brushing and spraying was left really to the discretion of the volunteers, but we recorded what they did. The quarantine space we used was very cozy. You'll see it in the bottom left-hand corner there. And it became challenging when COVID restricted the number of people in there to 4. At the start, I think we had something like 15 in there. In the end, we did about 1,300 tests for the presence or the absence of Phytophthora, and the results were analysed using binomial family, generalised linear mixed effects models with volunteer gender and age as random effects. So this graph shows the model results for equipment 1 for each component, which is on the y-axis, with the effect size on the x-axis. So a positive effect means that Phytophthora tended to be present on boots, and a negative effect means that it tended to be absent. The graph includes results for all soil and moisture types. So the Star Wars spaceships on the graph, on the body of the graph, comprise the estimate, which is the dot, and the 95% confidence intervals, which are the bars. So if the bars for two models don't overlap on the x-axis, they can be considered significantly different. So for equipment 1, the interpretation that I made of this graph is that all of the components of the equipment 1 were better than doing nothing, better than the control. Brushing alone or brushing and spraying with a disinfectant were better than spraying with PhytoClean alone. There was no difference between brushing alone and brushing followed by a PhytoClean spray. So spraying with PhytoClean doesn't improve the result. There was also no difference between brushing alone and spraying with metho. And so the best approach using equipment 1 is either brushing alone or spraying with metho alone. But it probably doesn't hurt to do both of them. Oops. So for equipment 2, the interpretation of the same type of graph is a little bit simpler. But so all components were significantly better than the control, doing nothing. Using a foot bath alone or a fixed brush with a foot bath were better than just using the fixed brush. However, since there was no difference between using a foot bath and using a foot bath and a brush, the foot bath is doing all the work for equipment 2. So comparing all of the equipment that we used for all soil and moisture types, we can see that using any of the equipment is better than doing nothing. There's no difference between using equipment 3, that's the fixed brush with the pump 10% PhytoClean spray, and equipment 1B, which was the brush with the spray bottle and the 2% PhytoClean. We can also see that equipment 1A, that's the brush with the 70% metho spray, was more effective at cleaning than using equipment 3. And equipment 2 was by far the most effective at cleaning the boots. Pulling the results apart by soil type and moisture, we can see where some of the devices ran into trouble. So for dry sand, all of the equipment removed Phytophthora from all boots. For dry loam, equipment 2 and equipment 1A removed Phytophthora from all boots, and equipment 1B and 3 removed it from most boots. For wet sand, equipment 2 removed Phytophthora from all boots, but other equipment was effective for about half of the contaminated boots. But for wet loam, none of the equipment was effective all of the time, but equipment 2 at least cleaned it 90% of the boots, whereas equipment 3 was unable to clean any of the boots. So we also made observations about the way the volunteers use the equipment, and some of these were a bit surprising to us. In fact, so we found that for equipment 1, when volunteers were asked to brush their boots without removing them, 2 volunteers couldn't actually reach the bottom of their boots and therefore couldn't perform the hygiene tasks. And for that reason, we had to change the experiment accordingly so that volunteers took their boots off and then cleaned them. And this has implications for field hygiene kits. Some people may not be able to use them unless they take their boots off or ask somebody else to do it. So the mean time spent brushing one boot ranged from 34 seconds in dry soil to 77 seconds in wet soil, and the mean number of squirts of disinfectant ranged from 7 to 9. So for equipment 2, the foot bath device, we found that a 5% PhytoClean foot bath was just as effective as a 10% PhytoClean foot bath. For equipment 3, the pump spray device, the number of pump sprays for one boot resulting in a positive test ranged from 1 to 14, and the time spent on the device where a boot tested positive for Phytophthora with wet loam was up to 4 minutes. That sort of time is probably impractical in real life. So what do we make of all this? I think it's important to note that all of the equipment that we tested was better than doing nothing and will certainly reduce the risk of Phytophthora spread. But how much they reduce the risk will depend on soil and moisture conditions. All of the equipment worked really well in dry, sandy soils, and none of the equipment removed the risk completely in wet loam soil. In fact, wet soils, either sand or loam, really challenge most equipment. The best portable hygiene equipment is a brush with 70% metho, and the best fixed equipment will use a footpath with PhytoClean. We did briefly try a clay soil, but when they were wet, boots were absolutely impossible to clean. For walking tracks through areas with clay soils, I think you can forget it for hygiene in wet conditions. We also started working on assessing vehicle hygiene, but that was curtailed by COVID and the fact that I retired and we ran out of money. Anyway, there were lots of volunteers to thank, and funding was from the New South Wales Government Saving Our Species program. Thank you.